Well, Unit 1 comes rapidly to a close very, very soon. Only a couple of days left in our unit. Lesson 8 in this pre-calculus reminder of limits unit is where we make the jump from the pre-calculus to the calculus when we come across the idea of tangent lines. That's what's coming up, tangent lines today. Couple of nice warm-ups, you'll do those when we're in class tomorrow. On today's show, I want to remind us of a couple of things. First, I want to find the average rate of change. The average rate of change, to make sure we remember what that is, for g of x equals x squared minus 3x on the closed interval 1, 3. And if we're going to find average rate of change, it has to be on a closed interval. That's the only way to get the job done. So a reminder to us, the average rate of change, side note, the average rate of change is the slope of a secant line. We figure out where the function is at 1, where the function is at 3, and we take a 9th grade slope. So the slope of the secant line is g of 3 minus g of 1 over 3 minus 1. Well, 3 minus 1 is easy enough. G of 3, that's 9 minus 9. G of 1, that's 1 minus 3. 1. Average rate of change, 1. At some point between 1 and 3, the slope is 1. That result will come later in our year. But for now, for us, average rate of change, slope of a secant line. Okay. That is different than instantaneous rate of change. The instantaneous rate of change is equal to the slope of a tangent line. And the tangent line is a line that ever so gently kisses a curve just once. It is what happens when you take the 2 points that we draw a secant line through and we let the two get so close together. And so you get something like this. Find the equation of the tangent line to y equals x squared minus 3x at the point 4, 4. And just reminding you what we're looking at, this is y equals x squared minus 3x. This is approximately the point 4, 4. There is a tangent line that hits that curve ever so gently once. And the way we do this is we take the slope of a secant from x equals 4 to x equals 4 plus h. And h is always a tiny positive quantity. It's a tiny positive quantity. We take the slope between x equals 4 and x equals 4 plus h, and then we let h get small. We let h approach 0, and we say, okay, I can't take a slope at one point because I still need a change in x. I've got to do change in y over change in x. Tangent line, there is no change in x, but I can take a slope between 2 points that are very, very close together and squeeze them. And so here we go. F prime of 4 is a limit as h approaches 0 of f of 4 plus h minus f of 4 over h. H is the difference between the x values. Change in y on top, change in x on the bottom. And so now it's algebra to the rescue. What is f of 4 plus h? F of 4 plus h is what we get when we take 4 plus h and substitute it for each x value. 4 plus h squared minus 3 4 plus h's. What is f of 4? F of 4 is what we get when we substitute 4 in for both x's. And I'm pretty sure that that is 4 over h. So we clean up the numerator. That's 16 plus 8h plus h squared minus 12 minus 3h minus 4. And that's glorious because all them numbers drop right out, and everybody that's left has an h. And so even though I can't let h get closer to 0 yet, because then I just get 0 on the top, 0 on the bottom, that doesn't make much sense, I can factor in h out and divide. And I can divide because h is not 0. It's a limit as h approaches 0, which means that h is not 0. And I ask myself, what happens to h plus 5 as h gets closer and closer to 0? Well, that gets closer and closer to 0 plus 5, and that's 5. This is the slope of the tangent line. If I want the equation of the tangent line, that's y minus y1 equals x minus x1 multiplied by the slope. And that's where the formula comes from. And that's what's going to pop up in the back of your book. That's the way it's going to pop up. There's no reason to isolate y. There's no reason to distribute the 5. You can leave the equation just like that. It is all good. Okay, do one more. Do one more, coach. Do one more. Okay, I'll do one more. I'll do one that's a little bit more abstract. I'll say if f of x is 1 over x minus 2, find, oh, here we go, f prime of x. F prime of x is the derivative of f. It's the slope of a tangent line at any point. And so I can do that. I can do that. But I'm going to do it in exactly the same way. I'm going to find out what happens as h gets small to the slope of a secant line. And the slope of a secant line is f at generic point plus h minus f at generic point divide by h. It is still a change in y over a change in x applied to the interval from a fixed point x to a movable point x plus h. And algebra comes to the rescue here. It usually does. F of x plus h minus f of x over h. Again, how do I find f of x plus h? I substitute the x plus h where the x is. So now I've got to remember what to do when I've got fractions within fractions. And the way we usually deal with that is we multiply everybody by the common denominator. And the common denominator here is x plus h minus 2 times x minus 2. X plus h minus 2 times x minus 2. Everybody gets multiplied by that. This is called socialism. So what's up top? When we distribute here, we get x minus 2. Minus what we get when we distribute here. The x minus 2's will cancel and leave us with x plus h minus 2. And your denominator, I'm just going to leave that in factored form because we can use it that way. Well, once everybody's done kung fu fighting, x drops out with negative x, negative 2 drops out with negative negative 2. You've got a negative h over h times that crazy stuff. Two things happen. One is that the h's can cancel because h is not 0. It's just close to 0. So we can cancel those out. The other is that we can substitute 0 for h now. And so as h gets closer and closer to 0, as the secant line looks more and more like a tangent line, the slope of that line is -1 over x minus 2 squared. That becomes the slope of the tangent line. So if I wanted to, as an extension, say I want the slope of the tangent line at x equals 4. Now I don't have to go back up to the top and run the whole definition again, f of 4 plus h minus f of 4 over h, take a limit. I have everything here, so I can just substitute 4 in for x and get -1 over 2 squared, and that's -1 over 4. I'm now able to find the slope of the tangent line at any point because I know the slope of the tangent line at every point. I'll do one more. I hope this is familiar to you. I hope you're at home saying, gosh, I could fall asleep. This is so familiar to you. Find the normal line to f of x equals 4x minus x squared at the point 2, 4. A normal line is going to be familiar to all of our friends from physics because we know that in optics, light bends toward a normal. And so you're already screaming at your screen, how can you do that to me? How can you say the word normal? Well, I don't care. So normal. Normal comes from the Latin word normalis, which means perpendicular. So what we're looking for is the line that is perpendicular to the tangent. And to figure out the line that is perpendicular to the tangent, you have to know what the slope of the tangent is. And to figure out what the slope of the tangent is, you have to know what the derivative is at 2. And we know that that's the limit as h approaches 0 of the change in y over the change in x. Change in y on top, change in x on the bottom, and algebra will rescue us. F of 2 plus h is what you get when you substitute 2 plus h for x. F of 2 is the y value at 2, and that's already been given to us, over h. Well, a little bit of algebra, not too bad. That's 8 plus 4h minus 4 minus 4h minus h squared minus 4 over h. And all sorts of stuff drop out. I mean, that's not true. Thank you, folks at home. No, wait, that is true. I mean, all sorts of stuff drop out. 8 plus 4h minus 4 minus 4h minus h squared. Right, right! Those go away, and we get, sorry folks at home, I got thrown off, minus h. Well, as h gets closer and closer to 0, that gets closer and closer to 0. So the slope of the tangent line is 0, which means the slope of the normal line is the opposite reciprocal of that. That's an undefined slope, and so we know that the perpendicular line has to be a vertical line. And the normal line, if it's going to be a vertical line going through 2, 4, has to be x equals 2. All right, those are broad stroke highlights. Those are broad strokes, big highlights. I have some OYOs for us to work on when we get to class tomorrow, and I will look forward to seeing you there.